In this problem, we want to discuss concavity and final points of inflection of this function. So we got f of x is equal to 5x times 3 minus x squared. Now, since this is a monomial and this is second power, I'm going to go ahead and multiply everything together. That's going to be the easiest way. So we got 3 minus x times 3 minus x. I could use a product rule twice and chain rule within a product rule and blah, 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 but not worth it. 3 times 3 is 9. 3 times negative x is negative 3x. Negative x times 3 is negative 3x. Negative x times negative x is a positive x squared, which gives us 5x times 9 minus 6x plus x squared. Now multiply the 5x through. 5x times 9 is 45x. 5x times negative 6x is negative 30x squared. And 5x times x to the third gives us 5x to the third. Now for our first derivative. Well, the derivative of 45x becomes 45 minus 30 x to second power, take a power, put it out in front, lower it by 1, plus 5 times x to the third, take a power, put it out in front, lower it by 1, which gives us 45 minus 60x plus 15x squared. Now for our second derivative. 45 drops away. Derivative of negative 60x is negative 60, and plus 15. Take your power, put it out in front, lower it by 1. Well, 15 times 2 is 30, so we got 30x minus 60. Second step, set that equal to 0 and solve. So we got 30x is equal to 60, or divide both sides by 30, and we get x is equal to 2. Okay, so now we want to build our table of intervals. Go over here is negative infinity. Go over here is positive infinity. We want to choose test cases. Something between negative infinity and 2, like 0. Something greater than 2, like 3. Now we want to plug those into our second derivative, which is right here, 30x minus 60. Probably overkill to put that in the calculator. So I got 30 times 0 minus 60, which is negative, which is concave down. And we got 30 times 3 minus 60. 30 times 3 is 90, minus 60 is positive, so it's concave up. So for concavity, it's concave down from negative infinity to 2. And then it's concave up from 2 to positive infinity. Now our POIs. Your POIs is where your concavity changes, which we see our concavity changes at x equals 2. Changes from concave down to concave up. So there's a POI right here at this critical value. Well, we need to find our y value. So we've got x is equal to 2. We're going to plug that back in our original function. Again, this is pretty straightforward. I'm not going to use a calculator. Put 2 in everywhere I have an x, so 5 times 2 times 3 minus 2 to the second power. 5 times 2 is 10. 3 minus 2 is 1. 1 squared is 1. 10 times 1 is 10. So our POI is 210. So that's the second part of our answer.